All of you see next topic, miscellaneous equations and inequations. See, this is third topic, that is miscellaneous equations and inequations. See, in this, first we need to know modulus function. Anyway, we have discussed about the modulus function. Okay, again I am discussing. See here, f of x is equal to, we'll say it as modulus of x. Okay, f of x is equal to modulus of x, that is a modulus function. Okay, so this is defined as plus x when x greater than or equal to 0 and minus x when x less than 0. Okay, so see here, for example, x is equal to, in place of x we are substituting some minus 2, then that is equal to modulus of minus 2, nothing but magnitude of minus 2. In that way also we can say. So you see here, this is modulus function. Okay, so f of minus 2, that means in place of x we are writing this minus 2 on both sides. Then modulus of x is equal to what? See here, here we are substituting a negative number, that means this is the case. So when x is a negative number, you have to take a negative sign before it, to get result as positive. Minus of minus 2 you have to write, then result becomes as what? Plus 2. Okay, so see here, what you can have, modulus of minus 2 is what? Plus 2. Okay, that same plus 2 only can be taken as minus of minus 2. Okay, when you are taking a negative number inside modulus, you have to give one negative sign before it. This negative sign before it, that you need to give, and that before that negative integer or negative number. Okay, so in that way modulus of plus 2 will gives us what? That is what? 2 only, nothing but plus 2. Okay, when inside modulus you are having a positive number, then you need to give positive sign only before it, then only result will be positive. Okay, when inside modulus you are having a negative number, you have to give a negative sign before it to become result as positive. Anyway, modulus should give result as positive, so that's why we need to give one more negative sign before a negative quantity. Okay, so this is about a modulus function. We can have its graph also. So I am going to give you the graph of modulus function. You see here, graph of y is equal to modulus of x. Okay, see here, x is equal to 0 we are taking, then respective y value is what? Modulus of 0, nothing but 0. From here 0 comma 0 is a point on the curve. X is equal to plus 1 I am giving, then respective y value is what? Modulus of plus 1 is equal to what? Plus 1 only. So respective point is what? On substituting 1 we are getting result as 1. So 1 comma 1 is a point on the curve. In that way x is equal to minus 1 I am giving, then respective y value is what? In place of x we are giving minus 1. Modulus of minus 1 is what? Actually minus 1 is a negative number. To become result as positive, you have to give one more negative sign before it, then you will get a positive number. So it will implies as what? See here, on giving x value as minus 1, you got result as 1. So minus 1 comma 1 is a point on the curve. Okay, so now we are having 3 points. Okay, so based on those we can draw its graph. This is y-axis and this is x-axis. On x-axis we will give x values, and on y-axis we will give y values. Y values nothing but what? Modulus of x values only. Y values are nothing but see here, modulus of x values, right? So see here, on the x-axis I am giving these values 0, 1, 2 like that, and on negative direction of y-axis -1, -2 like that. Okay, so first point is what? 0 comma 0, that point will be this one. And next point is what? Next point is 1 comma 1. 1 comma 1 point will be here when this is 1. Okay, see here, see here, that is 1 comma 1, and next point is -1 comma 1. So see here, -1 comma 1 point will be here, right? So this will be the point. So here we have given 3 points, 1, 2, 3. 3 points I have given. Now we are joining those. We can have graph like this. Okay, so this is graph of, see here, this is graph of y is equal to modulus of x. Okay, so in that way you see here, this can be taken as modulus of x minus 0. When you have 0 here, we can say that that is passing through point 0 on x-axis. Okay, now you see here, we can have graph of some other function y is equal to modulus of x minus 1. So here 1 is there. So graph will pass through the point 1 on x-axis. You can have, in the same way you can have the graph, but that is passing through the point 1 on x-axis like this. Okay, so this is graph of y is equal to modulus of x minus 1. Okay, so this is all about modulus function. Now we are going to discuss about step function or greatest integer function. See here, step function or greatest integer function. Greatest integer function. See here, f of x is equal to step x. We'll say this is as step x. So this is greatest integer function. Okay, so where step x is equal to greatest integer less than or equal to x, okay, is greatest integer function. See here, is greatest integer function. Okay, so now discussing about this step x. What is step x? See here already we have step x is nothing but greatest integer less than or equal to x. The same statement I am writing here. Step x is equal to greatest integer less than or equal to x. The same statement I have written here. So see here, in place of x we are giving some values on both sides. Okay, x is equal to 2.3 suppose. That we are giving on both sides, then getting us what? Greatest integer less than or equal to, in place of x we are writing 2.3 on both sides. Okay, so see here, this is greatest integer less than or equal to 2.3. okay, so you tell me a integer that is less than 2.3, so we can take it as 2, that is less than or equal to 2.3. we can't take 3. Why? That is integer more than 3, right? You can take 1, that is also less than or equal to, see here, less than or equal to 2.3. Next 0 can be taken. -1 can be taken, and so on. Okay, so these all are the integers, less than or equal to 2.3, correct? Okay, in all those greatest one is what? In all those greatest one we need to take. Why? You have to take greatest one, right? So 2 will be greatest one. So finally you can take this statement as, this statement means as what? 2 finally. Why? 2 is greatest one in all these, 2 is greatest one in all these, and these all are less than or equal to 2.3. These all are the integers less than or equal to 2.3. In all those, 2 will be greatest integer, right? So that's why 2 can be taken as the result. So therefore step of 2.3 is equal to what? 2. Okay. So you see here, step of, I am giving some examples. Step of 3.5. In the same way you will get it as 3. Step of minus 2.3 suppose. What about step of minus 2.3? So that is also greatest integer less than or equal to minus 2.3. So what are the integers less than or equal to minus 2.3? So you see here, minus 3 is an integer less than or equal to minus 2.3, minus 4, minus 5, so on. So these all are the integers less than or equal to minus 2.3. But you see here, you want greatest one. So in all those, greatest one is what? Minus 3. So minus 3 can be taken as the result, right? And on the left hand side, we are having step of minus 2.3. So step of minus 2.3 is what? Minus 3. Right. So I am giving one more example. See here. Step of minus 6.4. So that is equal to minus 7. Okay. In case of negative numbers, so you see here, you have to take this negative sign anyways. 6 plus 1, 7 you write. 7 you write. Okay. Again I am saying, you see here, in case of negative numbers, anyway you have to take negative sign. I have taken this negative sign. And you see this number 6. 6 is there, right? 6 plus 1, 7 you write. In that way you can remember, in case of negative numbers, and those should not be integers. Suppose step of minus 6 will give us minus 6 directly. So this is all when they are not integers. Okay. Inside step function, when you don't have integers, you can follow this. When you have integers, directly you write integer. Okay. Step of, in case of positive numbers, you see here, step of 2.3, what we got? 2. In case of positive numbers, directly you write integer part of this number. Integer part of 2.3 is what? 2. Directly you write that 2. Okay. In case of integers, step of 3. So directly you write 3 as result. Okay. Next, step of 0 will give us what? 0. Step of 0.1. This is also a positive number, right? You write this integer part as result. Okay. Next, step of minus 2.4. That will give us what? In case of non-integers and they are negatives, what I said, anyway you have to take negative sign. Okay, here 2 is there, 2 plus 1 you write. What is that? 3. Okay. Now step of minus 0.9 will give us what? Anyway this is a negative number, you write negative sign. Okay. 0 plus 1 is what? Plus 1 you write. In case of non-integers, negative numbers, you follow in that way. So anyway basic thing is step of x is equal to greatest integer less than or equal to x. So all these things we got from step of x is equal to greatest integer less than or equal to x. Okay. So that is the basic thing. So this is about step function, and graph of step function we'll discuss in functions. Okay, separately we'll discuss graph of the function, graph of the step function in functions topic. Next you see here fractional part function. Fractional part function. Okay. F of x is equal to, we'll denote fractional part function in flower brackets like this. So this is defined as x minus its integer part. Integer part is what? Step x. Correct or not? For example, you see here step of 2.3. Step of 2.3 will giving us what? Its integer part, right? 2 is its integer part. So you see here step of 3.5. Step of 3.5 is what? 3. So step function giving us what? Integer part, in that way we can say. Okay. So see here, this is what? Integer part. On removing integer part from x, anyway we'll have fractional part of x. So you see here is fractional part function, right? Now we'll discuss some points about this, and graph of this we'll discuss in functions topic. So you see here, in place of x I am taking 2.3, then getting us what? In place of x both sides I am taking 2.3, and then getting what? 2.3 minus step of 2.3. Okay, so fractional part of 2.3 is equal to 2.3 minus, what about step of 2.3? Step of 2.3 is what? 2, that already we discussed. Okay, 2.3 minus 2 is what? 0.3. So it all implies as what? Fractional part of 2.3 is 0.3. Okay, in case of positive numbers, directly you write this fractional part as result. Okay, actually basic thing I am writing again. Basic thing is what? This one. X is equal to integer part plus fractional part. X is equal to integer part plus fractional part, right? See here, x is equal to integer part, that means step x, plus fractional part. Okay, so you see here, now fractional part can be taken as what? X minus its integer part. Now we are going to get a fractional part of minus 2.3. Fractional part of minus 2.3 is not minus 0.3. Okay, for any number, fractional part will be a positive number only, not negative number. You see here, anyways, in place of x, we are writing minus 2.3 on both sides. Minus 2.3 minus step of minus 2.3. Okay, minus 2.3 minus, what is step of minus 2.3? Already we discussed, this is minus 3. Okay, minus 2.3 minus into minus plus 3. Minus 2.3 plus 3 will gives us what? 0.7. That is fractional part of minus 2.3. Okay, so therefore fractional part of minus 2.3 is what? 0.7, right? In the same way, we can, I am giving some fractional parts. Fractional part of some integers. You don't have fractional part, you write 0. Or you follow this, anyways you will get result as 0. Okay, next, fractional part of some minus 2.9. so that will gives us what? That will gives us what? 0.1. you see here 0.3, 0.7 giving us what? 1. 0.3 plus 0.7 giving us what? 1. Okay, So sum of these you should get it as 1. In that way you can remember, right? So now you see here, when we are writing 0.1, then only 0.9 plus 0.1 will gives us what? 1. Okay. Now fractional part of minus 3.2, that is what automatically. So see here, 0.2 plus what will gives us what? What will gives result as 1? 0.8. So that's why 0.8 you write as the result. Okay. So you see here, next. Already I said this, in case of positive numbers, directly you can write the fractional part. 4.6. Fractional part of this one is, directly you write 0.6. In case of positive numbers I am saying. In case of integers, in case of negative integers or positive integers, you don't have fractional part, you write 0. Okay. So this is all about fractional part function. Okay, and graph of this we'll discuss in functions topic. Okay, so these things you should know to discuss some problems in this third chapter. I'm going to discuss one problem. See here, the number of real solutions of the equation, the number of real solutions of the equation e power x is equal to x is. See here, first option that is 1, and second option 2, third option 0, and fourth option none of these. So you should get the correct option. See here. So first, what is meant by a solution? Solution means what? Value of x satisfying given statement, that's it. Solution means value of x satisfying given condition. See here, I am going to do it. That means we are going to get number of values of x, that's it. Okay, here given statement is e power x is equal to x. See here, e power x having different values and x having different values. Okay, but we may have that for some values of x both will be equal. So you see here, e power x values I am going to take as y1 and x values I am going to take as y2. Okay, so this is separate and this is separate. Let it be. So when they are becoming as equal, so when y1 is equal to y2, then we can say both are equal. So this equal symbol will satisfy, so that we will have corresponding values of x or number of values of x. Okay, so you see here, to get number of values of x, suppose you take a function, let it be y1 is equal to some f of x. Okay, and you see here, this is y2 is equal to g of x. This is what actually? F of x, and this is g of x. F of x, g of x. Actually, f of x and g of x having different values, but for some value of x, you see here both will get same result. Okay, suppose this is x1. At x1 you may have that f of x1 here only and f of x2 also here only, both becoming as equal. Again I am saying, you see here, f of x having different values and g of x having different values, like this, different values. Okay, so you see here, they are coming closer. You may have both will be equal at some value of x, okay, so at some value of x both will be equal, right? Such value of x is solution of, you see here, is solution of f of x is equal to g of x. Okay, So f of x is equal to g of x. So you see here we are going to take the graph of e power x and we are going to take the graph of x. Then we'll see where they are going to meet. Okay, how many contacts are there? You see here, for one contact you will have one value of x so that both functions are equal. So here you have to take see here at x1 you see here f of x1 is equal to g of x1. Okay, so see here from this f of x1 and from this g of x1, so both are equal, right? Again I am telling you, see here, these are f of x values and these are g of x values. Okay, these are f of x values and these are g of x values. So f of x having different values and g of x are having different values, but at point of contact you may have one value of x so that both will be equal. Okay, so you see here at this value of x both becoming as equal, right? So you see here at this value of x means when you have one point of contact we'll have one solution. Okay, when you have two contacts you'll have two solutions. Two solutions means two values of x are there satisfying both. Okay, now you see here we need to discuss this problem. E power x is equal to x. So you see here this is x axis and this is y axis. So y2 is equal to x graph will be like this. And what about e power x? Graph will be, you see here, on substituting 0 result will be 1. On substituting 1 result will be 2 point something, right? Y is equal to I think 2.321 like that. Okay, on substituting 1 you are going to get 2, so point will be here. On substituting 2, so you will get a 6 or something like that. On joining all those points you can have graph like this. This is graph of y1 is equal to e power x. So e power x graph is not meeting this x graph, so there are no point of contacts. So no point of contacts are there. Implies what? Given equation having no solutions. Okay, so see here, so which option is correct one? Option C is correct one. And we'll discuss some more problems in next class. Thank you everyone.